So I am interested in three aspects of black holes, and one is no-hair theorem. And black holes when they are formed, once they are formed, they can be described by just three parameters, right? Three physical quantities, and they are mass and electric charge and momentum. And no matter what kind of detailed processes might have been involved in the formation of a black hole, once a black hole is formed, you can just have two independent parameters to describe that. And since there would be virtually very little electrical charges, you can describe a black hole with just two parameters, mass and its momentum. And so that's called the no-hair theorem. And it's due to John Wheeler. And he famously said that black holes have no hair. And Richard Feynman was famously against it, thinking the term was kind of, stupid. But I actually love this expression, no hair theorem. So black holes have no hair. So this is quite interesting. So beyond the event horizon, there might be processes going on, but that's not apparent to us. So this would lead us to very philosophical questions like, okay, so we cannot describe, physical entity beyond a certain limited number of parameters because we can't know anything about that physical entity. But does it mean that there are nothing going on within it beyond the event horizon? So the no-hair theorem, puts before us a really interesting enigma, so to speak, about this kind of really singular physical existence. And the other interesting idea about the black holes is cosmic censorship hypothesis put forward by Roger Penrose, yes, our hero. And, this is the idea that there would be no naked singularity. Of course, in the middle, at the center of a black hole, there would be a singularity of some kind, which could be probably described in forms such as the Schwarzschild metric. But, since there is this event horizon again, and beyond that, we can't know anything in detail. So, Roger Penrose came up with this idea that in this universe, there are no naked singularities. So that's a really interesting idea. And this is the cosmic censorship hypothesis that I really love. And the other thing is that, Stephen Hawking showed that the entropy of a black hole is proportional to its surface. So it's not proportional to its volume, which would be the typical state of matters for conventional state of materials. But for the black hole, the entropy is proportional to the surface. And that from that, people have been inspired to think about the holographic principle, which states that the details of the properties in the spatial extension can be actually described, encoded on a lower dimensional surface, like two-dimensional surface. And this is a holographic principle. So, no-hair theorem, cosmic censorship hypothesis, and holographic principle. These are the three interesting aspects of black holes. And, it's quite amazing that when Albert Einstein came up with the general theory of relativity in 1915, just a month after that, Schwarzschild came up with the famous solution, which actually indicated the existence of black holes. So, maybe black holes are something that is so integral with the core of the general relativity theory, which describes space-time. And, we still don't have a really great quantum gravity theory. And, Roger Penrose and Stuart Hameroff thinks that maybe orchestrated reduction or objective reduction or whatever, the process in which quantum gravity effects would induce a wave function to collapse, and then we would have this classic world, and we would have made observations. These are at the core of the Penrose-Hameroff theory of quantum consciousness, and you never know. I mean, I'm not saying that there are black holes in the brain, and I'm not saying that black holes are relevant for neural functions. I'm just very curious about the possibility that these things, these ways of thinking, with some analogy and with some extension and with some equivalence relationship, might have some repercussions for the foundations of consciousness itself, and these I think would be probably be very helpful when we think about the computational foundations of consciousness, and especially when it involves quantum effects. And if you really think hard about the apparent non-locality of consciousness, of course, there's this really genuinely interesting possibility that quantum effects would be involved in consciousness, at the core of consciousness. And these things, I think, would be a really great inspiration, so to speak, when we think about the nature of consciousness. So all these things coming from the black holes, which actually is a very, very natural entity within the framework of Einstein's general theory of relativity.